Okay, welcome everybody. We are going to have the second session on distribution and networking. And we are going to start with the talk by Lorenzo Gheri, and collaboration with Nobuko Yoshida, I guess, on hybrid multi-party session types. Floor is yours.
Hi, thank you for having me. So I'll present today my work on hybrid multi-party session types, co-authored with Nobuko, and I'm Lorenzo, yes. So multi-party session types were introduced in 2008, and among the many features and nice things in the paper gives us global types. Global types allow for the formal specification of safe communication protocols. Disclaimer now, safe is my way, I use safe loosely, and it's my way to say, in short, something that carries good semantic properties. So with global types, I can specify communication protocols that are safe and with multiple participants that communicate with each other distributedly. In this work, our contribution is achieving distributed protocol specification. Namely, we add modularity to the formal design phase in multi-party session types. Now, multi-party session types, a brief introduction. Let's say we have this system with 3 participants, P, Q, and R. And the intended behavior is that P sends a message M1 to Q, Q sends a message M2 to R, and R sends a message M3 to P. Now, on the right-hand side, you see written in the syntax of local types, you see the implementation for each participant, which is distributed. So this implementation, for example, for P, P receives, question mark is received, exclamation mark is sent. So if, for example, for P here, the implementation would be that first P receives a message M3 from R, and then it sends to Q a message M1. Analogous for the other, as you probably have spotted, this system is deadlocked. So if the distributed implementation is like this, every participant has a receive action as the first one, they all wait to receive something, no one sends, and the execution is stuck. Then, of course, here we can do just checking the things, we can just swap the constructs in the first implementation so that P first sends to Q and then receives from R, and the execution goes well, everything is fine. Formally, the top-down approach of multi-party session types gives a way to specify a way to have this safe code by having a designer who specify a global type for the whole system. And as you can see at the bottom of the slide, there's this object called G, which is a global type that gives the full discipline of the system. So first there's a message from P to Q, M1, and then a message from Q to R, and then a message from R to P. It's like a scheduling. Now, so there is one designer specifying this protocol. The protocol is projected into the local types that you see that for each participant. Here I show in the slides, you can see the full syntax of global and local types. So in the previous slide, I presented the global message, so the arrow construct from P to Q, and the send, exclamation mark, and receive question mark for local types instead. Both syntaxes have the expressiveness of recursion and branching. With the syntaxes, again, here you have at a glance the top-down approach. With the syntaxes, a designer specifies the global type that is then projected onto local types, and processes can be type-checked against the local types. That on the right-hand side of the slide, I have an example on how good semantics properties are proven in literature. For example, now we pick label transition semantics, and the traces are equal for global and local types if the collection of local types is obtained by projection from G. So projection preserves semantics. In the rest of this talk, the main concept is global types. So what is specified with a protocol is safe. And I will indicate this safety with boxes as in the drawing there. Now, what's the good of multiparty session type? This safe design, so a formal design that guarantees safety. What is the bad? That the design is centralized. We are dealing with distributed systems, but if we admit, of course, distributed implementation, but not distributed design. And this work overcomes this limitation. The motivation is quite simple. When we deal with larger scale systems, there are many participants involved, and they exchange many messages among each other, and ideally they are specified in terms of components. So there will be more than one designer. Core idea behind this work is to have hybrid syntax, that's why hybrid type, that puts together the global and the local constructs. The global messages, this is important because I know it generates confusion, but the global messages are for internal communication, for intra-component communication. The intuition behind this might be that, I mean, for me is that the designer has full control on the message, namely both participants are in its component. While if the designer needs to send or receive some message from a different component, then well, it will use a local construct, namely a send or a receive. So I'll start describing an example of a company. A company with 3 departments, each department has a designer, and the designer specifies the communication of its component, of its department, with a hybrid type. In this case, we have the strategy department of a company, where D, the participant director, sends a product internally to ad, which is the participant responsible for advertisement. Now, the director decides on the product, so not only it sends it internally to ad, but to other components of the company, or more precisely, to other participants in other components of the company. In particular, D sends the product to S in the sales department and to F1 in the finance department. The price, so the advertisement responsible for advertisement ads needs to publish the ad and needs to know the price. The price will be decided, however, in the finance department and sent to ad by F2. This is instead the point of view of the sales department, where we have the participant S that sent the product. After receiving the product from D, it sends the product to W, which is the responsible for the website where the product is actually sold. Again, W needs to receive also the price from the finance department F2. And now the final specification of the component of the finance department. So first, as you can see also in the type on the right, F1 receives the product from D externally, sends an internal message from F1 to F2, so the product is communicated from F1 to F2. F2 will decide on the price and communicate it externally with a send to add and then to W. So this is how the system looks like at a glance. And I said before that safety is guaranteed by boxes in this talk. So we have 3 boxes that are not sufficient for the whole system, but they somehow verify, certify the internal messages. So the intra-component messages, the internal messages of each component. Now, what about the inter-component messages? They are not boxed. So we take a different point of view. We forgot about what we have already verified. We forgot about the components, and we box them. So we give a specification for safety only on for the inter-component messages. And this we give as a hybrid type or as a global type, so hybrid type with only global constructs, for compatibility. So we have one specification, separate specification for each component, and then we need an additional one, so n+1, for compatibility. Now, we have boxed the internal messages. We have boxed the inter-component messages. Our result is that this works. This can be composed, this specification, this modular specification can be composed in a global type for the whole system. So the whole system, the communication for the whole system is safe. This is our development at a glance. In particular, there is one novel notion that we had to introduce, which is compatibility. And the compatibility, once specified every component and the compatibility type, we check compatibility of each component against the compatibility type. So this is based on projection, and actually we had to extend projection so that we can project the compatibility type onto a set of participants, not only onto a single participant. This must be equal to the localizer of the component. What does it mean? That the localizer is the dual of projection. It's not true, but the intuition can be that. So the localizer preserves only the external construct of the type of such component. With this, as said, we prove compositionality, so we can compose and obtain a global type for the whole system, and we are safe now. Now, for applicability, there's one more thing we want, and we prove this too, that projection is preserved. So we don't have to build the global type G, because we are guaranteed that this G exists by the theory, but then we can obtain the local type locally in each component by projecting the component, of course, only in its internal participant. So we achieve some separation of concerns. I'm already at the conclusion. This is what we offer. We offer a theory for distributed protocol specification. We have introduced new concepts, and we have proven that our theory is sound, is correct. Now, the reason why I was so loose on the semantics is that this development is purely on syntax. So that system of global and local type is pretty standard, and it has, over the years, since 2008, it has been given many different kind of semantics, synchronous and asynchronous, for example. And no matter what semantics you give, as long as you rely on a global type, a well-formatted global type for safety, you can apply these compositional techniques. Therefore, there is compatibility with the existing multi-party session type system. Not only that, these techniques are pretty general in the sense that the concepts behind them, this development is ready for implementation, and we have sketched in the paper, we have sketched how to. But not only that, we have an example in the paper that these techniques can be extended to more sophisticated systems. So if the global types are richer, they, for example, have constructs for delegation or explicit connections, we can just redo the theory in a way, but reapply the same techniques. And as long as the theory is based on a global type projecting onto local types, these techniques are applicable. At the end, I will list the future work. As said, top-down implementation is on the way. It's pretty straightforward from this. And there you see what, in particular, we have in mind to apply these techniques to Scribble or Scribble-like design languages. There, and better in the paper, you can see the roadmap. Of course, this technique is ready for theoretical extension, as I said, but I'm confident that it can be brought further, so it can be ported to different formalisms for choreographies, so not only multi-party session types, but for example, choreography automata or choreographic programming. And then the last 2 points are interesting. The first one is very dear to me. I haven't done anything in this sense yet, but I want to mechanize this work in Proof Assistant, and I witnessed this love for Proof Assistant with the talk I gave a few days ago, ST30, the workshop for the 30 years of session types. Also, we want to change the perspective and apply these modular techniques, compositional techniques, to a bottom-up approach. So we start from the local types, maybe inferred from your programs, and then verify them. A first work on this was what my co-author presented at PPDP, again, some days ago in the contest of Splash. Thank you very much. If any question, I'll be happy to take them.
So if there are questions, you can approach the mic.
Can you hear me?
Yeah.
Okay. I'm very happy with this work because I think that finally, after 16 or 17 years of multi-party session types, we're making some progress. And this is just a teasing, yeah? One thing that I'd like to understand is that So you see, in traditional multi-party session types, you have the global type, and then you project into each one of the participants. So what I would like to see is this projection piecewise, so that you don't have to project in one go into all the participants. And I think this is what you're doing here. Can you go back a few slides, please, until where we have these diagrams?
This one?
So, yeah, so the traditional part is on the right-hand side, right? So on the left-hand side, you have 2 levels. Can you make it 3, 4, 5, 10 levels, or you have to?
I mean, you're not the first person asking this, so reviewers did that. Yes, you can. This work was very much driven by the motivation of what I presented, achieving this distributed specification. So I didn't think in terms of a hierarchy of levels connected by projection, but I thought in terms of having a global type. Actually, at the beginning, very naively, having multiple global types and putting them together. Then I had to open them with local constructs with hybrid type. But yeah, in principle, the theory is there. You had to add some parameters. I started sketching it, but you can definitely go more level up or
so
down.
You could decompose in 2, and then each of these in another 2,
yes.
and like this.
And you will have, of course, you will stop, if you start from above, you will stop at the level of local types. Okay. But if you're, for example, if your compatibility type, here is a global type, but if it's a hybrid type, so it's open, you could in principle first prove that there is a hybrid type for multiple components and then compose with something else with another compatibility type and other components. So yes, you can do this hierarchy of things.
All right, thank you.
Okay. Can you change?
Hey, thanks. That's very interesting. I wondered, like, have you considered, sorry, let me take one step back. If you consider the one component with the hybrid types, do I understand it correctly that, like, if you have an open communication to another component, you need to know which participant in that other component you are referring to?
Yes. We work under this assumption. Yes.
Yeah. Have you considered to, like, lift this to a more also abstract this in the sense of your motivation of distributing actually the design, because then you still need to know internals of the actual component that you might not know, right?
Yes, sorry, I'll take this question and then it's yours. So, yes, the fact is that in this case, I consider this a feature and not a bug. I'm not joking. I mean, previous work, they could compose only 2 components, and they use forwarders. So that's also in my PPDP paper with my co-authors. They are the previous work. They are the authors also of previous work. So they use forwarders. So if you want to, if you want a system or a composition where each component is allowed to send only to some particular participant, that's you can always do. You pick one in the component in this case. But this was an addition actually, with respect to what was in the literature.
Okay, thanks.
Yeah.
Okay, let's thank Lorenzo again.